Welcome back to the algorithm series, everyone. And for today, we will be discussing the insertion sort algorithm, the second of the sorting algorithms after the bubble sort. The idea behind insertion sort is simple. Imagine you're sorting a deck of cards in your hand, and in this case, we only have 5 cards. You start with one card, the very first card, and this is already considered as sorted. Because it is your first card, there's nothing to compare it against, and for our purpose, we consider it already as sorted. After this, we would proceed to the next card and compare it against our first card. Because 3 is less than 6, we would swap the position of the cards, and now it's considered as sorted. Afterwards, we move on to the next card, which is card number 3, and in this case, the number 7. We compare number 7 with the card before it, which is number 6, and if it's less than card number 2, we would swap that position. We would proceed to do this now until we reach the first card, or when the card that we have on hand, which is card number 7, is no longer less than the card before it. In this case, because number 7 is greater than 6 and 3, or the cards before it, then we consider number 7 to be already sorted, and we move on to the next card. Because king is greater than 7, it is already in the correct position. After this, we move on to the next card, and we determine that the last card, or card number 5, is less than the king, and therefore they swap position. This continues on until the card in question, which is the 2 of spades, is no longer less than the cards before it. Now that we know the intuition behind the insertion sort, let's start to code this. Let's define a function, insertion sort, that takes in an array of numbers. We know for the fact that the insertion sort algorithm traverses the array from the second element. Because, if you remember in the video, the first element is considered already as sorted. That for loop will be for I in range 1 to the length of the array. In this case, we are always comparing the current value, and that would be the ith element from the array. Now, the insertion sort always compares the current one with its immediate prior. So therefore, we'll use this j as an index, and this will be I minus 1, which is just the immediate value right beside the current one. As we've seen, we want to move the elements across the array and compare them. So to do this, we'll need to have two conditions and a while loop. So while j is greater than or equal to 0 and the current value is less than the array before it, right? Because we've coded j to be the index before the current one, then what would happen is that we want to move to the next value the element on the j position. So when we're comparing the current value with the value before it, if it's bigger, we want to shift that value to the right. And this goes on until we reach the first element. So to do this and to break the while loop, we want to diminish j by 1 every turn. Some documentation here. We want to shift the larger one position to the right. Now, this code will break when the current value is no longer smaller than the one being compared. If we've already moved the larger element to the position next to it, and we've already subtract j by this point, then we want to insert the smaller value or the current value to array j plus 1. The reason being, we've already diminished this by 1 at this point. So therefore, to insert it at the current place we are looking at, we need to add back that 1. And here we have the current. And after that, we will return the array. And in this case, we just put here insert. Okay. So let's see that in action. If we have a list of following number, and we want to try this one. We see that it's sorted, but let's explore this more in detail. Since we start at index 1, we assume that the first value here, 12, is already sorted. Now, we go and compare here the value 11. So, the current index is 1 and then j would be 0. This will be true, and the current value, which is 11, is definitely less than array j. In this case, the array j, which is 12 at the current run, is now inserted into j plus 1. Remember, j right now is 0, and therefore it will be inserted at index 1. So this will become 12, and j is diminished by 1, by which case right now, j would be negative 1. Because j is negative 1 right now, to insert the current value which we've saved to be 11, negative 1 plus 1, array 0, will be the current one. You'd best also see that in this particular case. For number 5, which is in the index 0, 1, 2, 3, index 3, and j will be equal to 2. J definitely is greater than 0, it's still 2, and then the current value is 5. It's definitely less than j2, 0, 1, 2, which is 13. j2, therefore, is moved to its next position, which is j3, so this one will become 13. And we diminish j plus 1, so j will be equal to 1. So you'll compare 5 again with 0 and 1. At this point, this should be 12 already because we've made the exchange. And because the current value of 5 is still less than that position, then we move that to, which j is right now number 1, array 2. And at 0, 1, 2, this will become 12. After this has become 13, this will become 12. And so on and so forth until we arrive at j negative 1, where now you add here 1, and then 5 will be at the first position. So hope this helps your understanding of the insertion sort.